Children, welcome to channel Sube. Today I am going to discuss question number 32, MCQ 32 of 2019 Physics new syllabus paper. Part of an orbiting satellite is coated with a metal that has a work function of 5 electron volt. The Planck constant is 4.1 times 10 power minus 15 electron volt second, and the speed of light is 3 times 10 power 8 meter per second. What could be the longest wavelength of incident sunlight that can eject an electron from the metal coating? So there are 5 answers in nanometer. Children, ejecting electrons under incident light is called photoelectric effect, that you must have learned. So in this question you don't have to worry about this orbiting satellite, because it's given to decorate this question. Just a metal, piece of metal, take into your mind just a piece of metal, say it's like this. So there are electrons, you know, in this metal like this. So why is energy required for the removal of electrons? Because it is bound to its matter by a certain energy, because there are bonds called work function. That energy is called work function, which is a characteristic of the matter. So to remove or eject the electron, you need an energy higher than the work function. So this word work function is given. You should know that. What is work function? So work function is what? The work function is the minimum amount of energy required to remove an electron from the surface of this metal. To remove this electron, you must supply some amount of energy. The minimum value of that energy is called work function. So we denote it by phi. So you don't have to worry about because this work function, the word is very heavy, but it is a simple idea. What is it? The minimum, that is the minimum amount of energy required to remove an electron from a metal's surface to infinity. So it is given here, 5 electron volt. So 5 is the work function, that is called work function, is equal to 5 electron volt. What is it? To break the bonds of this electron and let it liberate from this metal, the minimum value. So that is called work function. So what they ask us to find out is what could be the longest wavelength of incident sunlight that can eject an electron from the metal coating. When sunlight incident on this surface, it has energy. Sunlight has energy. So we call a packet of energy, that is a photon. We call photon. We call a photon to a packet of energy. We consider this wave as particles in this lesson. So what is the energy of this photon? We know it is given by E equals hf. So amount of hf given by hf is the energy that this photon has. So when this wave incident on this surface of metal, there are two things happen. One is breaking the bonds of this electron using this energy. The other part of the energy, the remaining energy, is used to give kinetic energy to this ejected electron. If it moves at a velocity v, the kinetic energy is half mv squared. So sometimes this electron might not have any kinetic energy. That means v equals 0. That happens when this input energy from the photon is very smaller, then most of that energy is spent to break the bonds, and then this ejecting electron has no velocity, therefore velocity is 0. That means this electron just liberates from this metal surface without any velocity. So that minimum energy, that minimum amount of energy is called this work function. No? So we can write the equation now. The energy that we have is HF. A part of it is used to break the bonds, that is 5. The other part of that energy is used to give kinetic energy. So these two equals to HF, that is the initial energy given by the photon. So now we know the basic equation. Why they have said in the question what could be the longest wavelength? Why do they want us to find the longest wavelength? So there are two types of waves, longer waves and shorter waves. So these shorter waves have high energy. They have high energy. So these longer waves have low energy. So they want us to find the longest wavelength. That means the minimum energy, spending a minimum energy, we have to eject an electron. So that means this electron has no much velocity. It just liberates. It just silently liberates the metal. So that means we have to take velocity of the liberating electron, ejected electron is 0. We can assume that. Then kinetic energy is 0. Kinetic energy is 0. As they have given this sentence, we can assume that this part is 0, because this electron doesn't want to have a velocity. It may be just liberate from the that is enough. Just liberating from the metal is enough. So that is the idea. So we can use then HF equals 5 plus 0. Then we don't have to write 0. Then HF equals just 5. So we have to use this equation now. So H is given 4.1 times 10 minus 15. Then frequency we don't know. They have not given frequency. But we can use V equals F lambda equation. But here the velocity of light, when we use light as the wave, we write the velocity as c. Then c equals F lambda. Then F equals c divided by lambda. So we can substitute here how this change. Instead of Fm, c divided by lambda equals 5. So we can substitute here 3 times, so c, now I am writing, h we have already written, 3 times 10 power 8. So divide by lambda we don't know, that is the thing we have to find out. Longest wavelength, that is the quantity we have to find out. So this work function is given in the question 5 electron volt. So they have given everything in electron volt, therefore we have to calculate in electron volt. So here the units are electron volt second, electron volt second. Here the units are meter per second. Here it's electron volt. So we don't know lambda, therefore we don't write units for what we don't know. But here actually in the real-time examination you don't have to write these units as you do in chemistry. In physics you don't have to write units in all the steps, just only the final answer need units. So we can simplify. We have to multiply this 4.1 by 3, 12 times, then this plus 8 cancel with minus 15, then minus 7, then divide by 5, equals lambda. We took lambda to this side, 5 to this side. So cancel, we can cancel this electron volt with this electron volt, and this second with this per second. Only m, that is meter, is what we get as final unit. So divide by 5 2 times, then 20 4 times, to 30 6 times, then minus 7, that is in meter lambda. But answers they have given in nanometer. So you don't have to simplify furthermore, because 2, 4, 6 digits are only in the answer 2. 683 800 1230. So this one must be the answer, children. But if you want, we can simplify this, because nanometer is what, 10 power minus 9. So you have to move this decimal point 2 times, then 2 4 6, this in meter. If we neglect this 10 power minus 9, just 2 4 6, then that is nanometer. So lambda equals 246 nanometer. So the second one is the answer. So children, I think you are happy. If you are happy, please subscribe my channel. See you tomorrow.